Hello everyone, welcome back. So, in today's video, we are going to see about ray diagrams, that is by concave mirror. So, when an object is placed in front of a spherical mirror at different positions, how an image is formed and what kind of characteristics do image be exist. So, what are those characteristics? Let us see. The characteristics of image is classified into four different types. The first one is location of image. So, by location of image, one can easily confirm that where does image is formed. So we can identify from this where does image is formed. Like different positions, right? So that one we can identify. And second one is size of image. So after drawing the ray diagram, so we have to identify after the location, immediately go to the size of image. So in this, the image can be a magnified one. See, there are classifications in this also. Image can be magnified one, or image can be a diminished one, and image can be of same size. That's it. So image can be a magnified one, image can be diminished one, and image can be of same size. And third one is orientation. So orientation of image. So in this orientation of image, there are two types. The first one, the image can be of erect and image can be of inverted. So easy to understand, erect means seedha, inverted means ulta. And the fourth one is nature. Right. So nature of image. So nature of image include two types, that is, one, it can be a real image or it even can be a virtual image. So we need to list out these four characteristics for every ray diagram of an object to locate its image or to find out the image by a spherical mirror. So in this video we will see about initially concave mirror, and then in an upcoming video we will see about convex mirror. So first we are starting with concave mirror, and for concave mirror the first object position we will see. Okay, so let us start with this. So the first object position is object placed at infinity. Clear? Object placed at infinity. So infinity means you can say just a far distant object, that's it. So even an object at sun can also be sun can also be considered as your object at infinity. Okay na? Just a knowledge based one. See, like this. So first though you need to draw your concave mirror as usual. So let us take your concave mirror and see, based on my adjustment I am just making the things which are quite required for me, and say this is your concave mirror, silvering on the bulged part. And then also we already know that what do we have, principal axis will be having, this is your principal axis. Clear? And then we will have some points, like what are they, fixed points, that is your pole, and then center of curvature, and exactly lying in the middle you will be having your focus F or focal point F. So now let us take this whole thing to some side, and then let us get duplicated it for our next usage of your next case, so that it will be easy for us to go through the diagrams quick. So now see here, when an object is at infinity, the first rule or condition we already know that when the object is at infinity, the light rays will be coming parallel to each other, and if that parallel beam was incident on this spherical mirror such a way that they are even parallel to principal axis. See, like this. So now we have got the light rays from the object which is at infinity. As the light rays coming from an object at infinity, the light rays will be parallel to each other, and that parallel beam was incident on the spherical mirror such a way that they are even parallel to the principal axis. So based on a rule 1 of concave mirror, light ray incident parallel to the principal axis, what happens after reflection? Yeah, very good. They pass through focus. So they pass through focus like this. So this is one reflected ray passing through focus, and then this is the another reflected ray passing through the focus. So thus the rules will make our diagrams very easy in this way. So now where did you see here? The two reflected rays are found to meet at focal point. You can see the two reflected rays are found to meet at focal point. So therefore what I can conclude now, image is first one. What is first one? Location at focus. Directly you can say image is at focus. Second one you can say this is looking to be a point sized image, that is your size, but I can say it is a highly diminished one. Okay, na? It will be a highly diminished image. And this one as highly diminished, we can say this is an inverted image, and as the reflected rays are meeting directly, we say that this is a real image. So like this we need to define the four characteristics of every image formed for different positions of your object. Now let us see the second position. Now the objects came some more a bit closer. So object beyond center of curvature. So object is beyond center of curvature. So what does this position mean? It is lying between center of curvature and infinity. This object is lying between center of curvature and infinity. So therefore I can take my object over here, see like this. So this is my object now. Clear all of you? So as usual, when an object is situated, what we need to do? The light rays we have to consider. So as usual, rule number 1, light ray coming parallel to principal axis. Already you have seen yesterday the rules, right? So light ray coming parallel to principal axis. What happens after reflection? Yes, you already know, right? That is, after reflection, the light ray will pass through focus. The light ray is passing through focus. Now take the help of any other rule, one more rule. So take rule number 2. So light ray passing through focus. Light ray passing through focus. What happens after reflection? According to rule number 2, after reflection it goes parallel to principal axis. Done. So now you can identify that the two reflected rays are meeting at this point. So if I draw an image over here, so this is your image formed. So therefore what I can say directly, image is right. First one, where it formed? It has been formed between F and C, and you can see, compare the size of the object and image. Image is a bit smaller, so therefore it is a diminished image. And third one, you can see the image was formed below the principal axis, so this is an inverted image. And fourth one, it is a real image. Because the reflected rays were meeting directly. So this is how you will be doing the things. And let us see the third one now. So before going to the third one, let us take this duplicate of this one, the mirror, so that it will be easy for us for the next diagrams. Right, if necessary we will take 2 more, if not, no need. Right, third one. An object has come a bit more closer for us. And third one, now it is object present at center of curvature. So object is located now at center of curvature. So let us take the object now. See here, this one. So object located at center of curvature. So let us take the object now exactly at center of curvature like this. Clear? Done. So next, as usual, rule number 1. According to rule number 1, light ray traveling parallel to principal axis. After reflection, what happens? It goes through focus. See children, for this one, please be careful with all your dimensions taken properly, because the image should be exactly on the C only again. So that is the reason, be careful while taking the dimensions and all calculations for this position. Okay, na? Be very careful. That's the only one instruction I can give you. And next, rule number 2, light ray passing through focus. Here I will adjust somehow to get my image straight away. So this is your the things. And now we are not getting the image exactly under C children, because I have just taken a rough calculations over here to do the such things, right? So what happens, and what if this diagram to be done properly? So exactly the image will be under the C only for this. So when you take the dimensions clearly, so you will be getting this stuff perfectly. Is that clear, all of you? So for that such things, I would like to just take the things a little bit up, so that it will be easy for me to do the things carefully, so that I will get all the dimensions perfect. So this is pole, and over here I am just taking, this is your center of curvature. And even though I would like to take the image readily before doing the diagram, and say this is your now what you call image straight away, so I could take from this one directly. So the image again will be at center of curvature only. So this is the only observation you need to follow the things, children. So therefore now what happens now, directly the reflected ray goes through focus. So this one it can be your focus. And say one more one, light ray passing through focus. After reflection it goes parallel to principal axis. So like this, now I can just show it that you have got the image exactly at center of curvature. So this is your focus. So just make sure that you are doing the things very carefully with all dimensions. So here I have just adjusted right, because we haven't taken any proper dimensions. So therefore image is formed at center of curvature. And second one, size will be of same size, and at the same time image will be inverted, and of course it is a real image. Of course it is a real image. And now one more thing, the object has come some more closer for us. So that is object between F and C. So if you have some ability to think, the case number 2 and case number 4 are quite opposite to each other. So see here, now I am just extending my principal axis and taking the object exactly where? Over here, between F and C. So the object is between F and C. Now rule number 1, light ray passing parallel to principal axis. Light ray passing parallel to principal axis, like this. Done. So now after reflection what happens according to rule number 1? It goes through focus. After reflection what happens? It goes through focus. And then what is your rule number 2? Light ray passing through focus is your rule number 2. And then light ray passing through focus, what happens then? After reflection it goes parallel to principal axis. It goes parallel to principal axis. So therefore see this one, a quiet adjustment I can just make it over here. So you will be getting the image straight after C. Straight after C you will be getting the image, that is image is beyond center of curvature. So image is first one beyond center of curvature, and second you can easily identify that image is magnified one, and third it is as usual an inverted image, and fourth it is once again a real image. See children, the distance between focus and center of curvature pole and focus should be equal, then only you will get all these diagrams accurate. That's the reason we are just trying to adjust our diagram a little bit wherever necessary. Clear? And now the last one, one more case was there for us. So this is your object at focus, a little bit more closer the object has been formed now, and the last one will be your object between pole and focus. So now let us see object at focus. So fifth position, object at focus. So let us go ahead with this object at focus. So as usual, let us take the object now. So we are just bringing the object, and now this is your object at focus. See, you can guess. Very good. That is your rule number 1. Straight away you can do this one. So that is light ray traveling parallel to principal axis. After reflection, what happens? They go through focus. After reflection, what happens? They go through focus. Done. It has been passing through focus. Now you can employ either rule number 3 or you can employ rule number 4. Any of the rule you can just take. So if you want to take rule number 3, you must be very careful like this. See, the light ray passing through center of curvature. Like this you have to take. The light ray passing through the center of curvature. So this is rule number 3 you will be assuming. If not, rule number 4 I can use. That is light ray incident at pole, making an angle theta. So for my convenience, I would like to take rule number 4, light ray incident at pole, making an angle theta. It also reflects with the same angle theta. It also reflects with same angle theta. Now you can observe that these two are parallel to each other. And even if I just extend this one behind, if I just extend backward like this, so these two are also going to be parallel one only. So it means here it is parallel, and at the same time here is also it is a bit parallel. So therefore both the cases it is parallel. So therefore I can say that image is located at infinity. That is very much important because the reflected rays are not meeting. So therefore image is at infinity. Yes, what you are guessing is correct. The case number 1, object at infinity, image at focus. Now object at focus, image will be at infinity. As image is at infinity, we cannot identify what you call this, whether it is erect image or magnified, what we can say. So first one, though, as it is at infinity, I can say the size of image will be highly magnified. It is said to be forming a huge image. And coming to the orientation and nature, see, if you are taking the direct rays downward, it is inverted, extended rays behind, it is erect. So therefore orientation you cannot identify, and at the same time real or virtual also you cannot say. So that's why the two characteristics when object is at focus is not applicable here. And the most important one, that is in the 6th case, when the object is located between pole and focus. So make sure children you are drawing this diagram a bit away from the margin. Okay na? Case number 6, object between pole and focus. Make sure that you are drawing this diagram a bit away from the margin. At the middle of the page you make it sure you are doing this. So let us take our object as usual. So object between pole and focus. So rule number 1, light ray passing parallel to principal axis. After reflection, they pass through focus. And rule number 4, sir, why not we use rule number 2, sir? You can use rule number 2, but it will be a bit complex. Rule number 3 also you can use, a bit complex. So for our easiness, we are using just rule number 4. So according to rule number 4, light ray incident at pole, making an angle theta. So it also reflects with same angle theta. So it reflects with same angle theta. Now you can see here the two reflected rays are diverging over here. See, the two reflected rays are diverging. So if they are diverging means obviously they might have started somewhere behind the mirror only. So let us take that extension now. So if I just extend this reflected ray back, and it is going to be in this way, and similarly if I can extend this one also behind, so you can see that the extended reflected rays were meeting at this point, yes or no? See over here. So this is the formation or location of your image, I can say straight away. So let us take the image. Done. So this is your image, and now we can say the characteristics of image as image is formed behind mirror. Very good. It is located behind mirror, and you can this size, the object size and image size you can see very bigger, right? So we can say this one as your magnified image. Very good. And as you said correct, it is an erect image because sorry, above the principal axis. And fourth one, image is formed by extending the reflected rays back, so therefore this is a virtual image. Thus we have seen the formation of image when an object is placed at different positions in front of your spherical mirror, that is your concave mirror. Hope you all understood, right? So we will see in our next video, that is object at different positions in front of your convex mirror. So thank you very much, children. Have a great day.